I want to acknowledge Dr. Gary Whiting, who's here from the Organismal and Environmental Biology Department. Gary's research goes in a number of different directions, including water quality, which connects best to our speaker today, who is Kevin Parker. And Kevin will go over his educational history, but my favorite part is when we had him. Kevin came to CNU for his master's degree, and we have what's been described as a boutique master's program. Dr. Whiting and I both chair a number of theses of students getting that master's in environmental science degree, and we always consider it very fortuitous when we find a student as good as Kevin. So Kevin has come back quite a few times because it turns out CNU is one of his favorite places to find employees, and he's going to tell you how you can do that. And you know, I can endorse it. I've gotten to work really close with HRSD, and my Wonders of Wetlands students know that when I talk about how wetlands improve water quality, I always say it's the same way that a wastewater treatment plant does it, right? So HRSD is the hero in my water quality story in that class. So I have a lot of reasons to appreciate Kevin being here today. But I always say I don't introduce people because their whole purpose of their talk is to say how you get to where they are. But I just wanted to add that even if you don't imagine yourself, for some strange reason, not deeply desirous of going to work for HRSD, you can see the strategies that he's suggesting really do cross. Also, they cross disciplines, so that if you're not coming here today as a scientist, I think you'll also see that Kevin's remarks have a lot of value. So without any further ado, let's welcome Kevin back. Thank you, Kevin.
Hello. First thing, I do want to see just kind of a poll of the room. Undergrad students, raise your hand. Grad students? All right, so undergrad. Science majors, biology, environmental studies. All right, non-science majors. All right, so the non-science majors, what are you majoring in?
Well, I'm double major in bio and environmental studies, so I'm do both.
Nice, back table. Somebody?
Theater.
Theater, very good.
Communications.
Communications,
Musical theater and history.
great.
Finance.
Excellent. Okay, so the good thing about this, my field of study is science. So I'm going to talk about the science side of it. I'm also going to talk about practical job application, getting jobs, steps that are universal. Doesn't matter where you're trying to get a job. But just to let you know, HRSD doesn't just hire scientists. We have engineers, we have lots of accounting, lots of finance, HR, and we do, believe it or not, are making lots of videos now promoting what we're doing, and we need people that understand video and theater, and we don't, because like scientists doing behind the camera are lame. It's terrible. Like they're so boring. So like now we hire people that actually know how to get behind the camera and like make it exciting. So hopefully something for everybody. A little bit about me. I am educated locally. Undergrad, Oldham University, environmental studies, chemistry, and then I said, wow, I actually started a graduate degree at Old Dominion, but they were not very friendly to me working full-time. I had a career already going at HRSD, and I did not want to give that up. It would have been very counterproductive to give up the career. So then I came to CNU and met some of these guys. In fact, Dr. Whiting was my advisor to get out of here. I made it. But that was the big thing, is he said, I'll work with you. Like our classes are in the evening, and you can work full-time. Keep a career going that will supplement, and then we're going to work as a partner. And so I ended up graduating. And now, granted, it took me 5 years because I was working full time, but you get through it. And CNU partnered with me, so there I was, Masters of Science. It's good for Newport. And then I went back to Regent to get an MBA. So it all starts tying together. People are like, you're a science guy doing an MBA. Well, yes, because when you start like managing in a company, you're doing science experiments, but you also have personnel. And you have finance, and all these things that go with it. And sometimes your sharpest scientists have a hard time managing the budget. So we needed people that had a little bit of background in everything. So there I am. I also do have a life, believe it or not. You know, this is my family. I go to watch volleyball. My two daughters, that's their big thing, is playing volleyball. So I spend my weekends doing that. And I have lots of interesting hobbies. I'm a scientist, but I don't like have a pocket protector. We do some interesting stuff. Like I like MMA. I do Brazilian Jiu-Jitsu. I'm an instructor of Brazilian Jiu-Jitsu, and I like to play the drums.
What kind of instructor is that?
Brazilian Jiu-Jitsu. It's like grappling, martial arts. So
On the floor.
yeah, violent, you know, get cuts and bruises. But it's good outlet, you know. So just know that, like, everybody likes to like stereotype groups like, oh, you work in a lab with beakers, you must be like, you know, sitting at home reading books. I do like to read books, but I also like to fight, you know, like controlled fighting, you know, internet. So there's a lot to talk about, but I do want to talk about HRSD and what I do for a career and things that are interesting. From an HRSD standpoint, so we have 9 major treatment plants. We were established in 1940. It's a company established basically to protect oysters in the bay. And here we are treating wastewater every day to the tune of a capacity of 250 million gallons a day. That's our capacity. We probably treat about 155 million gallons of wastewater every day. That's a lot of poo water, a lot of toilets flushing. It's an amazing thing to think about that volume of water coming through and us treating it to water that's of quality that can go out into the river. And the future for HRSD, my future all the way through my career is going to be now we are looking to treat it to better than drinking water quality. We're going to treat it where we can replenish the groundwater aquifer. We're already doing it. We're piloting it out in North Suffolk. So fantastic. Yes, you can watch the poo water come in and you can get a glass at the end and drink it. And I've done it and I'm fine. So it's the future for all of us. Now, what can I do with a science degree? And I'll open this up to, this is going to talk about what I can do with a science degree, but the steps I'll take later will apply to any major. Like 2 extremes here. This is what people think when you get you're going to get a degree in science. You're going to either look like people like beakers and like white lab coats, or you're never going to get a job because you're going to work at the mall and like that's just the way it's going to be. Your parents are going to be so mad they spend all this money and you don't work in science at all.
Ouch.
These are very extreme. There is a lot in the middle of this. I don't wear a lab coat every day. I mean, sometimes I don't typically, work in a lab at all. I do a lot of different science outside of that. So I'm going to show you the in-between and how to not end up not using your major at all. I'm going to help you, you want to work in the career and in the field that you've spent so much time getting a great education in. You could be a wastewater operator with a science degree. These are the guys. These are the guys and girls that make it happen. If you're a female, it's a growing career path for a large portion of females are now entering this because it was traditionally a male role. I think you're turning valves. It's like everybody's doing it because it takes a science mind, it takes a processing mind, and I'll talk more about the science behind this. This is microbiology. This is fascinating biology. You are the person that is now receiving this 9 to 10 million gallons per day at different facilities. We have 9 majors across Hampton Roads and treating the wastewater. Lots of science that we'll talk about. You also could just do local river monitoring. We have stations set up all over, smaller rivers, larger rivers, where we're monitoring continuous parameters. Yes, you could go out on a boat, and on a sunny day, it's as good as it looks. On a windy, rainy day, it's not as much fun. But this is just some surface water monitoring we do. We care at HRSD, we want to remove nitrogen. I'll talk about that in phosphorus, any macronutrients going into the river. Does anybody want to take a guess why we want to remove the macronutrients going into the river?
Because they tend to collect over time and we don't want the river to be bogged up by nitrogen.
Yes, and what would happen if nitrogen stays in the river and blooms what?
Algae.
Oh.
There you go, algae, which causes potential fish kills because you're loss of dissolved oxygen, all these things that you read about in science class. Well, it really happens. And we get on the boat every day, like 4 days a week, I'd say, and out of the Monday through Friday work days, and up and down the James River collecting samples, doing chlorophyll monitoring and other assessments to be sure that we can track and model these algal blooms and that we're not contributing to them. And lots of lake work we do, so if you take the limnology class, you'll actually see this stuff again. Lots of monitoring. Groundwater monitoring, that's a super fun site out in Suffolk. Came from treating lumber. They didn't realize that there's a lot of arsenic in this treated lumber that ended up in the groundwater, so now we monitor. This is a Campbellsville landfill. They just were monitored to make sure that the leachate from the landfill does not go so far into the neighborhoods and other things that are around there. So we have monitoring wells set up. Here you go, stormwaters. Used to be just monitoring stormwater. It's pretty simple. We cared about the water, and this, stormwater is not treated like wastewater. It just goes in. If there's no BMP or pond, it's going to go out into the waterway. But now this is so much more. I was just talking to Dr. Whiting. One of the big things we do at HRC is source tracking. We want to know that there's an indicator, a fecal coliform, some kind of bacterial indicator. Is it a human source? Because HRC will get blamed about, you have a sewer line that's leaking into our storm drain, and usually it's not us. Usually we do source tracking, and we can identify that this is a dog, and it's from people not cleaning up their waste, and now we have bacteria from fecal material that's not humans. Yes?
You also can recognize raccoon waste separately too, right? You can track it to that.
Yes, so when we first started, I thought it was these big circles. It was like, they kind of overlap. Here was human, here was kind of bigger animals like cows and dogs, and here were birds, and we hoped they didn't cross it. But now it's getting so specific. I mean, this is very, they're working with basically source identification of like DNA, RNA, so you end up being able to, say, I think this is raccoon based on all the indicators. This is dog, this is cat, this is human. So lots of science, and if you like microbiology, see, but it's not in a lab with a microscope. That's a tiny part of it. Just remember, microbiology is a tiny part in the lab with the microscope and slides and petri dishes and all that. Big part out in the field in the pipe, the storm drain, and collecting water samples and learning the process. If you like white coats and beakers, pipettes, and there's plenty of work. We have an entire laboratory. Any environmental work, you're going to have an opportunity to do this kind of work. This is perfect for some people. Prefer to not be outside, not be in the weather, in the same room, doing what you're good at, and that's fine. It's just a preference. I prefer to be outside. I kind of like to go around, see different things, but we have a lab that employs 60-some people. I want to talk quickly about the future of HRSD, but it's really the future of Hampton Roads water management, and that is our SWIFT, Sustainable Water Initiative for Tomorrow. It's a nice little acronym to sound good about recharging the groundwater aquifer. And I'll say, well, why is that important? Well, the natural aquifer, there's withdrawals coming from this aquifer. People use groundwater, and you'd be surprised at how much. I'll tell you in a minute. And it's not being replenished at the rate that it's being used. So we have a depletion of our natural aquifers, which does lead to land subsidence and saltwater intrusion from the saltwater into our aquifers. Also, just from an economic development standpoint, people, if they can't have access to groundwater, they may not bring their business here because they need water to operate their business. So there's a lot of factors. But this is what we currently do. Currently, as in for the past 75 years of wastewater treatment, surface water comes in, or we pull it from the groundwater, we use this water, and then we go through HRSD, we treat it, so at least it's not nasty, and we put it out into the river. What kind of water comes out of the aquifer and the surface water? Is that salt water or fresh water? That's fresh. Where the rivers and oceans around here, James River Ocean, what kind of water is that?
Salty.
Salt water. So we just take water that's drinkable, potentially if we treat it, clean fresh water, we treat it, and we put it out in the salt water. So we basically have, it's a one and done. So we said, with about $1 billion, which we found the funding to take care of. This is our SWIFT project. Very expensive, but this is a very creative management and use of funds. We're going to get there. And this is where we are now. Surface water comes in, aquifer water is used, HRSD treats it. But now instead of putting it in the river, we're advanced treatment. Better than drinking water quality. We're going to match the groundwater aquifer, where we then pump it back into the aquifer for recharge purposes. Um,